All right, it's 2 minutes after the hour, so let me go ahead and start. I'm sure some other folks will be joining us and wanting to hear today's activity, but for the sake of time, let me go ahead and start with the introductions. My name is Kent Messer. I'm one of the co-directors of CBEAR with Paul Ferraro, and we're very happy that you're joining us today. We've had a large number of registrants for today, and we're excited about this seminar series. It picks up from where we were at last year, and we have a great lineup of talks. I'll just talk a little bit about CBEAR because one of our activities is not only doing research ourselves, but making sure that people know about the exciting work that others are doing around the world and hear about this and be a network and community working on agro-environmental research and applying behavioral insights and testing things with experimental designs. And we've been working since 2014, funded primarily through the Department of Agriculture in the United States. We've been named a Center of Excellence through USDA, through our work, and we continue to be non-political. Our goal is to make programs work better for program administrators, for USDA, for taxpayers, for farmers and landowners, get the sludge out of these programs and use behavioral insights to be effective and feasible whenever possible, and test them, right? Make sure that this is working, really develop best practices for programs to show what works, how it can be cost effective. What doesn't work is one of the most important things that we try to emphasize on having good experimental designs to help us fail faster if need be, and of course, celebrate the victories when they are there. So we continue to work around the United States and the world, and I think today we'll really highlight our collaborations with people not only in the United States but around the world, whether it's in Australia or Europe and so forth. So we're very excited about that you're joining today, and I'll pass it on over to Mark Masters, our Director of Outreach for CBEAR. Mark.
Great, Ken, thank you. And so good morning, good afternoon, or good evening, depending on where you are. As Ken mentioned, my name is Mark Masters. I'm down at Albany State University in Southwest Georgia, and I work primarily on agricultural and natural resource policy issues. But today I'm honored to be in my capacity as Outreach Director for CBEAR. And that job mostly entails, as Ken sort of talked about, is telling that story of CBEAR and what we do and why we think it's important. But also it's about identifying and developing and certainly maintaining really strong partnerships, whether it's with academia, government, nonprofits. And early on, we thought it was important to highlight others that are doing similar work in our space and doing good work. And so in 2016, we awarded the inaugural CBEAR Prize for agro-environmental innovation. And you see Laura's put the previous winners on the screen here, and anywhere from the chief of NRCS back in 2016, Jeremy Peters and Sheila Reddy with nonprofits that are strong partners of CBEAR, the Commission on Evidence-Based Policymaking, and then recently last year, Dr. Marka Weinberg from the Economic Research Service. And so as we were thinking about the 2021 prize, a group of researchers really came to the top of that discussion, and that is the Research Network on Economic Experiments for the Common Agricultural Policy, or REECAP. And we are pleased today to present them the 2021 Prize for Agro-Environmental Innovation. And the REECAP mission, and I'll just read it so I don't mess it up. It's a European Union-wide research consortium created in 2017, so a couple of years after CBEAR, to bring together researchers, evaluators, and policymakers interested in the use of economic experimental approaches for more evidence-based policy design and evaluation, ultimately to improve the EU's common agricultural policy. So if you Google around, you will see that REECAP has been quite successful in developing that network of researchers advocating for the additional use of experimental and evidence-based work to evaluate the common agricultural policy, and then doing quite a good job in disseminating their work and developing those partnerships. And at CBEAR, we've been pleased to be part of that, and some cross-pollination with webinars like this. One of the REECAP work group leaders will join us in March for one of our seminar series. So hope you'll join us for that. But today we've got Marianne Lefebvre from REECAP on with us, and she is accepting the prize for REECAP this morning. So Marianne, congratulations and thank you for being here.
Thanks a lot, and good morning, good afternoon. I'm very pleased to be here today on behalf of the REECAP board. And as you mentioned, we are all over Europe, and I will take the time to mention the name because it's really a collective work. So we have Jens Pannell in Sweden, Lisbeth Cullen in Germany, Sophie Toyer in France, Tanya Sumrada from Slovenia, Laure Kufus in Scotland, Fabian Thomas in Germany, Jesus Barrero in the European Commission, but based in Spain, and myself, Marianne Lefebvre from France. So we are very honored that our research network on economic experiments for the Common Agricultural Policy, REECAP, is considered as a leader in the field of behavioral sciences and experimental design to improve programs related to agriculture and the environment. And for such a young organization as REECAP, receiving the CBEAR prize is really a recognition of what the network can do to support both researchers and decision makers. And it's a strong encouragement to continue our efforts to bring experimental methods into agri-policy analysis. And we would like to warmly thank CBEAR selection committee for this prize. I would also like to take the opportunity to thank persons that have been engaged previously, Raphaël Préget and Uwe Latax-Lohmann, as well as Karen Blanchflower, which is acting as communication assistant for REECAP. So as you mentioned, we were born officially in 2017. Since then, the network has grown quite a lot. We are currently funded by a French research fund called Alliance Europa, but we are actively seeking funding to consolidate our activities. Yet something I'm very proud and happy about is the agility of REECAP. It's not an organization, it remains a network open to all, those who want to contribute. The board has evolved since its creation. It relies on volunteer work and benevolent collaboration between researchers and policymakers. And this is, I think, very important to all of us. So before we became REECAP, some of our members had been collaborating with decision makers in the European Commission. We investigated the value added of experiments compared to other methods that are currently used for CAP evaluation. Later, some of us engaged in discussions with national ministries, agricultural chambers, or water agency to launch randomized evaluation. As you know, as you mentioned, these partnerships are very difficult to build, but some of our attempts were successful. As you can read in the special issue coordinated by REECAP in the European Review of Agricultural Economics in 2019. And we had a workshop annually where many discrete choice and field experiments were presented and discussed. We are also very proud that some PhD students who have benefited from REECAP activities have advanced in their careers and they have now joined the board. Concerning our relationship with CBEAR is nearly as old or as young as our organization. In 2018, we had Kent Messer giving a keynote lecture in Vienna, followed by Paul Ferraro in 2019 in Osnabrück. So we believe the challenge we are facing are the same in the EU or in the US. We believe REECAP can learn from CBEAR experience, and that's why we regularly promote your publication and webinar in our newsletter. And we also believe that in the future we may collaborate on cross-national data collection or work on methodological issues together. So we have identified two main challenges. One on the quality of our research. We have webinars on promoting methodological advance, promoting open science practices. We had this big replication project that will be presented by Jens Pannell on March the 7th. So just to provide a teasing for this webinar, we replicated an experiment that was initially run with 100 farmers in France, and now we replicated it with more than 1,400 farmers in 11 countries, European countries. So that's quite a success. And the second challenge where we need to to go further, is to enhance the impact of our research. So to do so, we try to engage in bi-directional knowledge exchange with policymakers. We always try to have a roundtable with policymakers in our annual workshops in order to disseminate the culture of experimentation and to communicate on results. And this is always very insightful to listen to Kent or Paul, because I think they are very good in explaining what is experimentation and how we can convince program managers. So finally, I invite you all to check our website, recap.org, to learn about our activities. And I also take this opportunity to invite you to submit your research. So we have the 2022 workshop that will take place in Uppsala early June. And the deadline for submission is March the 1st, so you are still on time. And thanks again for this recognition. We hope that our future activities will live up to this prize, and we will continue pursuing our transatlantic collaboration, hoping to make faster progress towards counterfactual evaluation for evidence-based agri-policy making. So enough from my side, and I think it's time to learn from Dr. Pannell in Australia.
Yeah, almost. Thank you so much. That was really great, and congratulations. So my name is Laura Paul. I am a postdoctoral researcher with the Center for Behavioral and Experimental Agri-Environmental Research, CBEAR, and I'm going to give a couple housekeeping things and then introduce David shortly. So first, like last year, we're going to use the chat function to take all of your questions. So throughout the seminar, please submit your questions via the chat. The chat will be moderated. Some of us might help respond if it's a quick, easy clarification. And then all of the questions will be sort of curated for a question and answer session led by Mark Masters at the end. So everyone's going to remain muted. And then the last thing is to make sure to join us next time as well. I'll put a plug for Dr. Leah Palm-Forrester as our next speaker. So I'm so happy to introduce today's speaker. Dr. David Pannell is a professor of agricultural and resource economics at the University of Western Australia. We are very grateful that he was willing to tune in at 10 p.m. his time to join us at this time. David is a director for the Center of Environmental Economics and Policy, an ARC Federation Fellow from 2007 to 2012, Distinguished Fellow and past president of the Australian Agriculture and Resource Economics Society, and really the list goes on. So we're so excited to have this expert and sort of outstanding speaker to kick us off today. So David, I'm going to stop sharing my screen and let you get going.
Thanks, Laura. Let me just share my screen. Okay, how's that?
That looks great.
Okay. Well, thank you very much. And thanks very much to CBEAR for inviting me to give this presentation. I'm going to be talking about some work that dates back to a sabbatical I took at the University of Minnesota just prior to the onset of COVID. And we were working on a number of different sort of sustainable agricultural issues. I'm going to focus in on agricultural water pollution, particularly that related to nitrogen. And I'm not really a behavioral or experimental economist. I'm more of a farming systems production economics sort of a guy. But I hope that I'll be able to highlight a number of ideas and opportunities that you'll agree are very relevant to behavioral and experimental economics. So this is the plan. I'm going to start by talking about a range of opportunities to reduce water pollution coming from nitrogen fertilizer from farms. I'm going to identify a number of neglected or forgotten or never known, or at least never widely known, findings from production economics that have really important implications for policy, but also, I think, for behavioral and experimental economics. That includes some cases where there are some pretty clear discrepancies between farmers' perceptions and the empirical evidence, which obviously is bread and butter to your world. And I'm going to finish by talking about adoption of agricultural innovations, which is an area that I work on quite a bit, and demonstrate the use of a tool called Adopt to understand and predict adoption, and make some comments about the potential usefulness of that tool in an experiment as a sort of a precursor to experimental economics. All right, so I'm talking mainly about nitrogen, and nitrogen usage has grown dramatically around the world over the last 70 years or so. These graphs are for corn in the US. The left-hand graph is the rate of nitrogen application. You can see that it took off dramatically after about 1950, grew exponential or extremely rapidly for a decade or two, then still continued to rise at not quite the same pace. And the right-hand graph is corn yields, pretty much the same starting point, continuing increases at an even more continuing rate. So nitrogen isn't the only reason, clearly, why those yields have increased, but it certainly is one of the most important factors that's contributed to dramatically increasing yields, not just of corn, but of many crops all around the world. So that's a really positive story. It's contributed to farmers' incomes and reducing hunger in a really important way. However, there has been a significant negative externality arising from the use of nitrogen fertilizer, and I've got some photos here from Europe, from Asia, from the US, highlighting the impacts of fertilizers and what they can do to water bodies of various types. So clearly a significant off-site problem to be addressed. And of course, it's a problem that has received an enormous amount of attention. There's an enormous amount of research, and many different policy initiatives have been attempted. I guess my observation to date would be that the policy initiatives have not been highly successful. They've been at best moderately successful. And so one of the a factor that triggered what I'm going to talk about was an approach that we had from a large agribusiness firm to advise them on potential low-hanging fruit for ideas and issues that they could address or promote that could help improve the sustainability of agriculture. And within this area of agricultural water pollution, we think we identified something that is sitting there and is still a low-hanging fruit and could potentially make quite a big difference. And this is in the area of nitrogen. So I'm going to talk about, the way we started this work was to review a range of different methods that farmers could adopt to reduce their nitrogen losses from off the farm. So I'm quickly going to run through a bit of a spectrum of those. It won't be a comprehensive list, but a variety of approaches that can be used. One of them is the use of cover crops between the main crop growing times to capture moisture and nitrogen nutrients within the field and sediment as well. Another is zero-till, which means includes the maintenance, usually maintenance of crop residues within the field, as you can see here. So this is an approach that also can help to reduce losses of nutrients to some degree from agricultural fields. Buffer strips, replacing vegetation between the crops and the water body to capture nutrients that are moving through the surface or the shallow groundwater. Nitrification inhibitors, that's application of chemicals to the soil to change the populations of microbes in order to stop or reduce the conversion of nitrogen from relatively immobile forms into relatively mobile forms. Variable rate technologies, which is trying to match the application rate of nitrogen to better suit the needs or the responsiveness of crops in different physical locations within the field, and reducing fertilizer rates in general, or nitrogen rates in particular, as a very simple way of meaning that there's less nitrogen there to be lost. So these and other methods we reviewed, and there's obviously a lot of opportunities, a lot of options here. We characterized them in a fairly simple way on the basis of whether they were relatively cheap for farmers to adopt or not, and relatively effective at reducing losses of nitrogen from agricultural land or not. And so that breaks us into a nice 4-quadrant diagram. And you can see that those actions I mentioned and some others fall across the spectrum of the 4 different quadrants. We've got some things that are relatively effective, but somewhat costly. We've got some things that are cheap, but not necessarily so effective at reducing nitrogen losses. We've got some things that don't look particularly good on either dimension. But we do have one thing that is both cheap and quite effective at reducing losses from agricultural fields, and that is the reduction of nitrogen rates. So that is one of my take-home messages, that nitrogen rate reduction stands out amongst the available options as being a very good way, and in my view, the single best way, the best opportunity we have to reduce agricultural water pollution related to nitrogen. So I'm going to present 5 reasons why I believe that to be the case, and this is the first of them, the fact that it appears to be the only option that is both cheap and highly effective. I'm also going to run through a set of what I'm calling untapped opportunities, which sort of arise from production economics, but have much broader relevance and importance. The first of these is the observation that a significant number of farmers appear to over-apply nitrogen in the sense that they apply more nitrogen than would even be in their own best interests. So this raises the possibility of win-win outcomes. The numbers in this table are from a USDA publication from a few years ago by Tara Wade and others. And you can see that for these crops, there are significant numbers of farmers, between about 20 and 36%, who apply more nitrogen to their crops than an identified benchmark rate that these researchers used. And they over-apply nitrogen on average by quite a substantial amount, by 24 to 40 pounds per acre. I'd comment that the benchmark rate that they used appears to be determined on a biological basis rather than an economic basis. And my suspicion is that if it had been an economic rate, that all of these numbers would have been even larger. Now, there's been quite a bit of research looking at possible reasons why farmers may over-apply. And I'm going to focus on 2 particular ones that I think are most important. One is possible misconceptions about the shape of the profit function. Here are some results from an old paper by Sri Ramaratnam, who looked at grain sorghum producers in Texas. And that group of researchers found that farmers systematically overestimate the impact of additional nitrogen relative to the empirical evidence. And very interestingly, that they maintain their beliefs about this even after seeing experimental results conducted in local fields. So this jumped out at me as a possible avenue for research in the behavioral economics, experimental economics. There's something going on there to understand. It looks extremely odd that they're maintaining these apparently incorrect beliefs, misperceptions, or biases, if you want. So there seems to be an opportunity to dig into that and perhaps try and turn that around. So I'm going to suggest some policy options for these various issues that I'm throwing up. For this particular option, I've listed extension and the possibility of developing nudges, some sort of nudge type intervention to reduce bias. I must admit, I'm not that optimistic about extension because there's been a lot of extension trying to get farmers to reduce their nitrogen usage. And you'd have to say it hasn't been all that successful. So I think we need something a bit different, a bit innovative, and maybe nudges might be an opportunity there. The second opportunity, which I'm calling Untapped, relates to risk. And this is arising from the fact that many farmers see nitrogen as a risk-reducing input. But when you talk to farmers or farmers' advisors about what they're thinking when they say that, it seems to be not a very sophisticated view of risk. And often what you get is something like nitrogen reduces the probability of a low yield. But if you think about that, that's not really much of a statement about risk. That's more of a description of the production function. And there are much more I think, relevant and appropriate ways of thinking about risk and the effect of an input on risk. And personally, my advice to a farmer who asked my advice on this, I'd be asking them to look at the variance, or some way of simple way of thinking about the variance of profit at different input rates. That's a way of thinking about risk that doesn't seem to have had very much attention at all in this argument about why farmers might overuse nitrogen. But our old friend Sri Ramanratnam did so, and actually did a survey of farmers to understand what they thought about the variance of profit at different nitrogen rates, and confirmed, at least for that sample and that area, that farmers did think of nitrogen as being risk reduction in the sense of reducing the variance of profit as you went to higher rates. That is the only study I can find that's looked at this issue in what I consider to be a good way. That's a pretty striking result, because the evidence, the empirical evidence, is absolutely clear, and that is that nitrogen does not decrease risk. There's any number of data sets from around the world. I can pull out data sets from Europe, the US, Canada, and Australia that all show that nitrogen does not decrease risk. In fact, if anything, it probably increases risk, at least within some ranges of nitrogen. So here's a data set that some new results we haven't published yet. This is work with Yuan Chai and Phil Pardee, looking at a number of different data sets from the Midwest, corn production, either corn after corn or corn after soybeans. And the horizontal axis is the nitrogen rate in kilograms per hectare, and the vertical axis is profit. And these are box and whisker diagrams. So the dark little bar in the middle is a median, then the box is a 50 percentile range, and then the whiskers is basically a confident, like a 95% confidence interval. And you can see, if you look at, say, this range here on the left-hand graph, that if it's changing risk at all, it's increasing risk as you go to higher rates. And once you get above sort of getting towards what would be economic rates, which is sort of in this range, it really doesn't do anything. And over here for corn after soybeans, it seems to do pretty much nothing for any as you change rates across the whole range. And that is pretty much the results that I see anywhere. I've not seen a set of comparable results that doesn't really look like that. So I'm very confident in asserting that around optimal rates on a whole range of different crops in many different countries on many different soil types, nitrogen has almost no effect on risk. And as I said, this seems to be a clear misperception by a significant number of farmers. So policy options here, well, this is one where I think maybe there is a bit of a role for extension, because I don't think that this issue has really been extended well. I don't think the information has been put across in extension in a way that would convey what's really going on in a way that would be compelling. But of course, there could be an opportunity here again for behavioural and experimental economics to get involved to try and reduce the biased perceptions that many farmers have. And because we're talking about risk, maybe there's a possibility of looking at novel insurance mechanisms as well, perhaps insurance that could compensate farmers for their losses if they were willing to take the risk, the very low risk, of reducing their rates. So that's an idea that has actually been looked at a little bit. There was a pilot scheme that did exactly that in the Midwest about 10 years ago, but it didn't really go anywhere, despite some quite interesting results. And recently I saw a paper by next month's speaker, Leah Palm-Forster, and some colleagues. They did an interview with farmers on a range of different policy approaches, one of them for increasing agricultural sustainability. And one of them was this. It was about insurance to compensate farmers if they adopt BMPs. And interestingly, they found in that study that the farmers weren't too keen. They seemed to be particularly concerned about transaction costs that might be associated with insurance. But I'd still say that there's a lot, this is an area that deserves more attention. There's really not been much attention given to this, and there's a lot that could still be done. The third untapped opportunity is what I call flat payoff functions. And this is one a little bit like the risk results that I just showed. I think this is really underknown. It's an issue that even economists have not paid sufficient attention to. The issue is, this is a data set from my state, Western Australia, and it shows the profit as a function of nitrogen application rate for a wheat crop in a particular circumstance. And you can see that the highest point on that graph tells us that the optimal rate of nitrogen is 82 kilograms per hectare. But the really striking thing is that any rate between about 42 and 138 gives within 95% of the maximum possible profit. There's this enormous range of input rates, of nitrogen rates in this case, that gives almost optimal returns. And I think this is really important. And it seems really, as I said, really quite neglected. In the case of economists, I suspect that what's going on is that we're so used to dealing with things in marginal space that we don't stop to graph absolute things like absolute profit. And you don't see this unless you're looking at absolute profit as a function of the inputs. But you can probably immediately see why this might be important. So, for example, here is the results for that same data that I showed earlier for corn in the Midwest. This time, it's the profit function in relation to N rates. The coloured lines show the full profit functions for a range of different trials in a whole lot of different locations, different contexts. The dark lines, the black lines, or the little dots show the maximum profit point, and the black lines show the range, or how far you could reduce input rates, nitrogen rates, and not lose more than 5% of the maximum profit or gross margin. And it's really huge, right? There's a 40% range on average in these trials, and that's absolutely typical. It's not just these are not unusual results. I see these sorts of results across all types of crops in all countries. I've never seen a data set graphed in this way that doesn't look like this. Okay, so there's a really big opportunity here to reduce rates at low cost that seems to be underappreciated. I've said there 40% for a 5% reduction. If you're a little bit more conservative and say, well, we'll go for a 30 to 33% reduction, you can get that for only a 2 or 3% reduction in profit. So it's really low cost to get large reductions. Potential policy options here. Extension, again, I think this is an issue that's widely underappreciated, not just in the extension and agriculture, in economics, but also amongst farmers and their advisors. Again, nudges, perhaps. This time, I think there's an opportunity to foster public spiritedness in the way that behavioral economics has tried to do that with things like, power bills. You sort of show people what other people are doing and try and get them to behave in a publicly spirited way. Here's an opportunity. The great thing about this is you can say to people, you could make a massive difference and deliver large public benefits at very small private cost to yourself. And that if presented in a creative and effective way, might be very effective at influencing people. And then the third option here could be payments, just a payment-based scheme, because as I've shown, you can get large reductions at low cost. If you design it in the right way, you could tap into that. All right, so that's 4 out of my 5 reasons, the initial one, and then those 3 untapped opportunities. My 5th reason why I think that lower nitrogen rates is a fantastic opportunity is that it has very unusually high possibilities of adoption. If you've done research on adoption of agricultural innovations, and you think about what are the characteristics that are needed for an innovation to be highly adoptable, I don't think I've ever seen an innovation like a sustainable agricultural innovation that ticks so many of the boxes as lowering nitrogen rates does. So here's just 8 criteria. There's probably more I could put up, but 8 key ones include that you can do this at 0 cost or very low cost. It's very simple to trial. You just lower your rates with your normal setup. It's easy to do. You don't have to do anything complicated. It's very easy to understand what you're doing. It's just completely familiar, really. You're not doing anything that's hard to interpret. There are no upfront costs. You don't have to buy any new equipment or infrastructure. It's easily reversible. So if you go into it thinking, if I don't like this, can I get out of it? Then you can. So there's no option value in not doing it. So, there's no reason not to try it. It's only using completely familiar technology, and it's highly effective at reducing pollution or generating public benefits. So for those farmers who are motivated by delivering public benefits, you can make a case to them that this is a way that they can do that at low cost to themselves. So for all those reasons, it should be one that can generate high levels of adoption. And I would say that of all those other ideas that I showed you, all those different methods that farmers could use to reduce their nitrogen losses, there's nothing that comes close to this in terms of ticking so many boxes, indicating that ought to be highly adoptable. So let me reiterate my 5 reasons why a focus on lowering nitrogen rates should be something of a great value. Firstly, it should be cheap and effective. Secondly, there is already over-application by many farmers. So there's at least for those farmers, it can be a win-win. There are misperceptions about risks held by many farmers and some of their advisors. I raised the issue of flat payoff functions, which shows the potential for large benefits at low cost, and unusually high potential for high adoption. So why aren't we doing it? What should we do? How much of it could we get? So to me, this begs the question, well, I'm making the case that this is an approach that could be highly adopted. How highly? What realistically could we expect in terms of a level of adoption of this practice? This practice being reducing nitrogen rates below business as usual rates. Well, in trying to predict that, there's a number of different ways you might approach it: lab experiments, field experiments, farmer surveys, maybe extrapolating from published evidence. But I don't think any of those would be all that helpful in this particular circumstance because of the misperceptions that are so widespread. So what I have done instead is use a tool called ADOPT. ADOPT is the Adoption and Diffusion Outcome Prediction Tool. It's an online tool to predict voluntary adoption that has been developed by a multidisciplinary team in Australia that I'm part of. The team includes quite a range of disciplines. There's agricultural economics, rural sociology, agricultural extension, and specialists in farming systems. And over a number of years, we collected a large volume of research evidence about adoption of innovations, a lot of data sets about rates of adoption and levels of adoption, and a lot of work on reviewing and understanding the research evidence about that. Of course, we were left with some knowledge gaps, which we filled with a number of expert workshops. And where we ended up with was a tool which we used to predict the peak level of adoption and the time lag until that peak level will be reached for a specific, well-defined practice or innovation for a particular well-defined population of farmers. This tool's been used for a few years now. It's got a large user group. We've got about 1,500 registered users across policy, R&D funders, extension agencies, and so on. As part of this process, we had to develop, or we felt we needed to develop, a novel conceptual framework to help us explain and quantify these adoption parameters that we're trying to predict. We did look closely at some of the, well, all that we could find of the existing frameworks that were out there. There are quite a few ways that people have suggested of thinking about adoption. We weren't satisfied with any of them for our purpose, even the sort of the best known ones like the theory of planned behaviour, for a couple of reasons. One is that they tend to be quite high level, and we wanted to be able to explicitly include quite a number of important variables that had come through in the research literature as being important influences. And the second important reason was that most of the frameworks out there deal most explicitly with the people side of this story, and the technology or the practice side is a bit buried. Sometimes it's completely buried, other times it's sort of implied. And our strong view was that that adoption is really a question of combining the people understanding the people and their relationship to the technology. And we need to bring both of those understandings together. And I guess it's a long-standing frustration of mine that much of the research on adoption of innovations has undersold or underplayed the role of understanding technology. And I hope I've actually sort of demonstrated that already by what I've presented on the production economics of reducing nitrogen rates. There's important information there about the technology that is really critical to thinking creatively and well about ways that we could approach improving the adoption of that practice. Okay, so I'm not going to go into all the details of this framework. There's too much to it, but I'll just point out that it's in a 4-quadrant diagram. I seem to like those. The top 2 quadrants relate to variables that relate to the population. The bottom 2 relate to the innovation or the practice. The left 2 boxes relate to learning about the innovation, and the right 2 relate to the relative advantage or the profitability or the net benefits of adopting this practice. And again, there's important variables in each of those quadrants, and they all come together to predict, as I've said, peak level and the time lag until adoption. I've used this tool to look at a number of scenarios that relate to the issues that I've talked about already. I've got some scenarios that relate to farmers' perceptions about the profit impacts of this practice. So I've done these for Midwest corn farmers for the practice of reducing nitrogen rates by about 33%. I've completed all of the different questions. There's 22 questions in the framework, reasonably realistically, I think. But there's some specific things that I varied in a systematic way. One is, what do farmers think would happen to their profit if they reduce their nitrogen rates? I've allowed for some farmers potentially thinking that it could cause a moderate profit disadvantage or a small profit disadvantage, or probably the most realistic one, that they'd more or less break even, and it may be even for some a small profit advantage if there's a payment involved, or maybe they've over-applied. And then down here, I've got some scenarios relating to risk perceptions. I've allowed for farmers who think that if they reduce their nitrogen rates, they would suffer a moderate increase in risk or a small increase in risk, or the realistic one, which is that there'd be absolutely no change in risk. And then this one is about farmers' interest in protection of the environment. So this is worded in the way that it's worded in the Adopt tool. How many farmers have protection of the environment as a strong motivation? And I've looked at 2 of this 5 different levels of that in the tool, a minority or about half. And so a quick reveal, I've solved the Adopt for all those combinations and come up with a number of predicted peak levels of adoption. I'm not going to talk about the time lag. I'm going to focus on the peak levels. And you can see they vary quite a lot, but let me, rather than sort of try and struggle to take all that in, let me walk you through this quite quickly. So first of all, let's suppose we have an intervention to provide information about flat payoff functions, and we could change farmers' perceptions one way or another away from thinking that they would suffer a moderate or a small profit disadvantage to them thinking that it would be more or less break even. Then their adoption levels, adopters predicting, would go from about there to about there. So they're not massive, they're not huge changes, but there's something. It's not a panacea, but it's certainly a contribution. If you could go even further along there, maybe by the introduction of payments to take people even beyond that, we could get at even higher levels of adoption. All right, so that's that one. If we then looked at interventions that provide information about risk, or maybe we develop an effective insurance instrument, and we managed to change farmers' perceptions about reducing nitrogen rates, so they no longer think that it'll be a moderate increase if they cut their rates, or if small increase, but it'll now be a no change, then we'd be able to change Adopt predicts. We'd be able to change their adoption percentages. I should clarify that this means the percentage of farmers who adopt reduced nitrogen rates from sort of those numbers to those numbers. Again, particularly over on the right-hand side, quite helpful changes, although again, not dramatic, not panaceas. And the third one is, this is the sort of the pro-social delivery of public benefits type behavioral economics intervention, perhaps. If we could convince farmers to change from a minority being interested in the environment to about half, we could again increase the adoption rates a bit. But of course, the ideal would be to do all of those. So if we started perhaps realistically with people who think that there'll be a small profit disadvantage, oops, let me go back, a small increase in risk and only a minority being pro-environment, we could go from 3% up potentially up to over 50% of farmers adopting reduced rates. Okay, I've almost finished. A few quick observations and then I'll wrap up from that. So I think one thing that jumps out from those predictions is that achieving targets for high adoption of reduced nitrogen rates will require significant effort and resources. Despite my claims about high adoption rates, it will still require pretty significant effort and we'll need combinations of policy mechanisms to achieve the targets, because it looks like we've got to change things on several fronts to get up to about 50% adoption from where we are now, which is pretty low adoption. And again, I'd comment that that's for nitrogen rate reduction, which I still believe is our best approach, our best option for success in this space. And that most of the other practices are less attractive, and in fact, significantly less, and much less likely to achieve those sorts of levels of adoption than I was showing. All right, my final slide. I want to leave you with a few take-home messages. This is my sort of what would I want you to remember in 3 months about this presentation, if you could only remember 3 things. The first thing is reduce nitrogen rates. I guess I've hammered that. I think it's our best hope. Second one is understand the technology. Don't get too wrapped up with only focusing on the people. Adoption, behavior change is a combination of the people and the technologies. And the third one is, perhaps it's flagrant self-promotion, but use adopt. I think that I hope you can feel that there's opportunities to use a tool like this, perhaps as a sort of a test bed prior to thinking about and planning experimental economics interventions, in much the same way as experimental economics is thought about as a test bed for real policy. Maybe this is a test bed even before that, because it's very cheap, very quick, and it might help you in all sorts of unanticipated ways. Okay, I'll stop there.
Oh, great, David. Thank you. Appreciate that. Very, very good information. Prompted a good bit of discussion in the chat. So thank you to all of you that weighed in there. So I'm looking to try to consolidate some of these. And so, David, you mentioned, and you kind of started here. You talked a lot about the benefits of reducing the N rate and why this is kind of the cheapest way to go, but we don't seem to get that adoption on the farm. And so one of the commenters said, okay, well, what are we missing? There's all this evidence. What are we missing? And you talked a little bit about, and someone else kind of labeled it, this misperception. And a specific question, do you think, or can you speak to, is that misperception of the experimental results, the box and whisker stuff? Is it because they're understanding at the farm level, and you're showing some kind of median value ranges, and do you think it's just a misperception of the data versus what they see on their farm, or what do you think is going on here in terms of their lack of adoption based on the experimental results?
Okay, a couple of things. I think that there's a lot more to learn about this. I don't think there's been research to understand why there might be biased perceptions, but I've got thoughts. One thought is that it could relate to the flat payoff function idea that I showed, which means that farmers can get away with over applying nitrogen at very low cost to themselves, because it's not just flat on the downside, it's flat on the upside as well. So if you are applying, 20, 30% more nitrogen than you need to, or that would then even would be on your own best interest, you're probably not really going to notice it. You're not going to take a hit in the hip pocket for that, because the reduction in profit from doing so is so small. And so if you take a sort of an approach, which from some of the farmers that I've spoken to about this, they sort of say, well, yes, I know I probably only need to apply 150, but if 150 is good, maybe 180 is better. And they don't lose from doing that. They don't lose personally, but the environment loses. So I think that's one thing that's going on. And then I guess that in the area of risk, I think risk is hard to think about. I think risk is a very complicated issue, and that I don't think many farmers that I deal with think about risk in a very sophisticated way, and that there's probably scope to help with that.
Yeah.
At least in this area. Maybe they think about risk and price management in a much more sophisticated way, but specifically for this.
Yeah, and I guess I wanted to follow up on that a little bit, and this wasn't specifically in the chat. I'm taking, I guess, moderator's privilege, but there's been a lot of survey results out there. Most recently, I saw a document from the Soil and Water Conservation Society that they really talked about how the importance of the early adopters on the farm. The thought leaders, the farmers that are out there doing it, as they put it, quote, highly effective at encouraging adoption and conservation. So, can you speak to that in any way? We kind of talked about the experimental stuff via extension isn't moving the needle. Have you looked at these early adopters using them and some of their on-farm, their neighbors, in other words?
I think
that way.
I think extension is well aware of that as an issue, and that has strategies that often attempt to tap into and get the thought leaders to be influential. For whatever reason, I don't really know why it hasn't worked, or they haven't tried to use that approach for this issue. I haven't got much more to say than that, really. It's not something that's really been emphasized in the literature in this space.
And so we had a number of questions and a comment too about the nudges. So we kind of set up the what we think is the answer. Speak more to some of those nudges you think might work.
Well, I sort of hinted at one. Well, I was explicit about one of them, which was the possibility of using the opportunity that you've got this practice that can deliver high public benefits at low private cost. As I say, I'm not a behavioral economist, so I wouldn't deign to suggest how you approach that, but it seems to me as a sort of a novice in this space that surely there's an opportunity to tap into that. I realize that this whole space is a little bit underutilized. Lots of the behavioral economics work that's tried to use those sorts of nudges has been in the consumer space rather than the producer space. So so we don't really know how effective this approach might be, but I guess I'm putting this forward as if there's ever going to be a good opportunity, this is surely it, because of the nature of the production economics that we're dealing with. In the other cases, the risk and the perceptions related to overuse, the first two that I mentioned, I'm not so clear what those nudges might look like. People on the chat can probably do a better job of identifying those, but I think it's crying out for people like the audience here to dig into it.
Yeah. And so we had a couple of what I think are really fascinating comments thinking about some of the other things that might be at work here.
Yeah.
One of them in particular, it's not just the 1 year risk, right? Particularly here in the U.S., as farmers going through their production, those yields that they're making one year go to their average that can then flow downstream. So there's that, and I guess related, with this emerging, whether it's carbon markets, payments for ecosystem services, why adopt now if I can get paid later? Like, why lower my baseline? You think any of that's going on?
Okay. Don't know. It's not really. One of the reasons I've raised this is because I think the whole issue, when you look at the programs that are paying farmers money to do things, I think the issue of rate reduction is underdone. people are being paid to do a lot of those things on that list that I presented at the start. And often you see programs that don't even mention reduced rates as a thing. They look at rate splitting, which is sort of related, but it's not exactly the same. But they're doing all those other things. And you only sometimes see rate reduction as being mentioned. And it should be the first one on the list every time, in my view, right? I'm sorry, I've got a bit lost from where you started.
Yeah, no, just kind of one of those other things to think about that might be keeping certain producers from
risk.
adopting
Yeah,
this.
the risk one. Yeah.
Do I need to wait to make this cut and get a bigger payment?
Yeah. Okay. So where I was going with that was thinking that because it hasn't been widely talked about or used as a mechanism, as a target for payments, my suspicion is that it's not farmers holding off, waiting for payments for that, because it's not really one that's been done much, you know. On the risk one, there is another factor which I didn't raise, which is the possibility that in very poor years with low yields, some of the nitrogen remains in the soil and is available to the following year. So there is a sort of a moderation of the low end risk in that case. In general, though, nitrogen doesn't hang around for all that long. It's not like phosphorus. Phosphorus hangs around for years and years. Nitrogen's quite mobile or can volatilize through the soil surface. So it's moderated to some degree, but it's there's still I still hold that this story about risk being a very minor factor in the story is true.
Yeah. Well, David, I'm conscious of the clock. It's telling me we've got to bail out pretty quick. I wish we could keep this discussion going. I am dropping in the chat just now. One of our participants, Lisa, thank you, sent me a link to an article about some work over in the Chesapeake about this very thing, where they were looking at, you know, farmers and their perception and how they actually experience some yield loss. So I encourage you to check that out. This recording will be available on the CBEAR website. We'll have all the Q&A discussion included, and any links and other information that we get in, we'll be sure to pass along. I see some other things popping up in the chat. Sorry we couldn't get to everybody, but a very good discussion. And David, thank you for staying up late and joining us. Very well done. And would remind all of you to register and plan to join us in 2 weeks when we have Leah, who I see there on the screen, is going to present in our next in the seminar series. So with that, we will conclude this with once again our congratulations to REECAP. Marianne, thank you for being here again as well. And I hope you all have a wonderful rest of the day, and thank you for being with us.